Okay, off we go. All right, so yes, this is our first official week. What I do in the first week is I do a very quick review of some Python concepts. It's not going to be like at the same pace all the way through, so no, it's not a complete review of Python. Really, all that I'm doing is just sort of reminding you of a couple of things. This is mostly for you to deal with your first lab, and sorry if you've already had your lab. The first week is always like this. We get things a little out of sync. If we actually start on Sundays, life is much, much easier, but we always start mid-semester or midweek these days. But in any case, so it's really just meant to be just a quick reminder about what input, output, computation, variables are, and so on. No, we're not going to be spending like this much time on everything. Really what I find is the first week I don't get a lot of people, so I'm just trying to fill up some time. Like for example, I won't spend a whole lot of time on if statements because everybody understands those. We will spend a little bit of time, probably next class, on loops, and in particular for loops, because that would be something new. So don't worry, it's not like suddenly this becomes infs1201 again for a whole bunch of time. It's really only this week and next week, and then it's all brand new, difficult material, I promise. In case you're wondering that, oh, it'll be boring. No, it won't be boring and easy. It'll be challenging new. Okay, maybe that's not what you want to hear. But in any case, here we go. So the way I deal with this, I tend to jump back and forth between slides and the interpreter because I usually find that running stuff in the interpreter is a lot more interesting because of a couple of things. Number one, I will tend to make a lot of mistakes, which I like doing. I know you don't like making mistakes, but I like making mistakes because chances are it'll be the same mistakes that you make, and sometimes even I make mistakes on purpose so that you have a chance to see what it looks like because, well, trust me, I've been through here enough times to understand what people have misconceptions about. All right, so here we go. A very quick overview and review of Python. I try to hit things that I think might not have been covered in INFS 1101. I try to keep the topics down to exactly the things that we will do. That's not helpful. I try to keep it down to the topics of things that I know are really, really critical for this course. So yes, there are lots of things in the Python language we don't talk about, but this is our coping mechanism because otherwise we'd be stuck forever doing nothing. All right, so here's what we're planning to cover today, something about variable strings, number basics, and formatted strings, F strings. Chances are you've probably seen most of these. All right. If I came in, now this is a lot more interesting if I do this in the very first week, but because I've already had some students in the lab this week, you kind of know the answer. If I gave you this problem right now and said, okay, here's a computer, here's an interpreter, please write this program, I was going to ask the questions, if you had to do this right now in order to take this course, could you do it? No, I won't ask for a show of hands because maybe you don't want to say that, oops, no, maybe I couldn't. So, I mean, I guess just the question is can we do it? And I have to say this because sometimes I do get students in the course and they look at this and they go, yeah, well, if I saw an example, or I've taken the prerequisite like 5 semesters ago, well, sorry, this is not even a 1201 problem. This is really an INFS 1101 problem. So the answer is, yeah, I should be able to do it. So this is just ask how many, so we're counting things up. It really is an 1101. I guess the next question is, okay, ask yourself, how long would it take for you to go from absolutely nothing to the point where you could actually do this? Okay, and again, you don't have to answer that question, but maybe answer to yourself because obviously, hey, this is a review. And if you say it's going to take a really long time, my recommendation to you is to go and do a whole bunch of review of 1101. Okay, like there's only so much I can do here. I'm just reminding you of a couple of topics today. I can't teach 1101 in the course. And how long of a program do you think it is? Okay, well, here's an interesting thing. Sometimes I get students to ask this, or sometimes I'll ask students, and I'm just talking about kind of an overall size. Like, is it 2 lines of code? Is it 10 lines of code? Is it 50 lines of code? Now, when I say 50 lines of code, sometimes in 1201 people go, 50 lines of code? Okay, well, to be honest, in a real-world program, that's a joke. Okay, programs that are considered small in the real world are programs that are less than 100,000 lines of code. That's a small program. Okay, so no, it isn't 50. Yeah, we really scale things back here. And we can do it because having really big programs with things you understand is not going to help you if you're still having problems dealing with small programs. But in any case, just to remind you, yeah, so what would you have to do with this? Okay, we have to do with some input, you have to do with some calculations, you have a bunch of looping because you know you have to repeat this, and you have a bunch of if statements to figure out whether or not something was over or below 45 degrees. Yeah, eventually we'll get there. So we'll answer this question in a couple of weeks. Or sorry, next week, I guess, a couple of classes. All right, so input and output. Okay, so this goes back to infs1201. Why are these things really important? Okay, well, you have to think about what a computer is actually used for. Well, what it was designed for in the first place. A computer was really designed to be a replacement for a calculator. Okay, calculator, yeah. You think about a calculator. Calculators are great because they can add up numbers, but the thing is it can't, I mean, if you have to add up a bunch of numbers, you can easily make mistakes. You're sometimes doing a lot of calculations over and over again. You have really big complicated formulas that need a lot of steps, and really computers and programming was put together to simplify it. Believe it or not. So for some people who say, oh, okay, I've taken the course a couple of times, still having problems getting through with it. Yeah, imagine doing this stuff without a computer. Okay, that's actually the thing. But in any case, input is really important because you need to be able to interact with the user to say, hey, these are the values, what values would you like me to deal with? And you as a user using a program, yeah, programs that just do things on their own without your input, they exist, it just isn't that particularly useful. And of course, output is very important because if you don't have any output from your program, it means that the user has absolutely no idea what happened, and that is completely useless. All right, so of course, almost every program in the world deals with the user for input or output, possibly both. Not always, by the way, but usually they do. And, of course, well, we also have the program, which is the actual calculations. Okay, so let's actually move into this, and again, as we kind of remind ourselves of these things. So here we go. Let's put this away, and I will more or less do the same thing. All right, so here we go. This is the interpreter that I use in class. This one you have access to on the assessments. You're free to use this in the class, and you're also free to use idle during the class. It's no problem if you want to use that one. But I'll be using this for my demonstration. All right, so here we go. Let's start covering some stuff. The easiest thing that I always start with whenever I'm covering a new language is output. Why? Well, because it's the thing that the user can see. Dealing with input isn't very much fun because you can't see it. Because you're just asking the user to type something and then fine, maybe it's input, maybe it isn't. Calculations are also kind of dull because, well, they're not very interesting. The output is probably the most important thing. And you're going to see me use a lot of output in my programs even if I'm not asked for it. Why? Because it gives you the chance to see what's going on the inside. Maybe before you do some calculations, or maybe when you're making decisions, and you will see an awful lot of this. Okay, so the important one here today, and then I'll introduce some things. Maybe you've seen them, maybe you haven't. All right, to make something appear in the world of Python. Okay, well, in a programming language itself, it's just an output statement, but in the world of Python, you've seen it before. The command is called print. Oh, excellent. If I try running this right now, does it print anything? No, this actually falls into something, and I know it's covered a bit later. This would be called a syntax error, and what I'm going to do is I'm going to let the program run. Oh, sorry, where's the program? Ooh, actually, it doesn't seem to do anything. All right, does it print anything? Well, I don't know. I didn't see anything. But of course, if you look carefully at this, what I've done is I basically said print nothing. Hey, we accomplished something. It wasn't very useful, but we accomplished something. The usual way how you print something is you put some parentheses, and you stick one of a few different things. Okay, so here we go. The types of things you can put in. There you go. There's something. Okay, now, I can't remember. I know I got an email message at the end of one of my classes. I can't remember if it was this one or one of my other sections, so just I'll remind you as well. While I'm dealing with this, you have to be quiet. Okay, here's a hint today. I don't believe the attendance is being taken. So if you don't want to be here, it's completely fine. But what I don't want you to do is I don't want anybody who's here who's talking disturbing the people around them. Okay? So I can't remember if it's this section or the other section, but while you're here, I'm doing stuff. Sorry, you have to be quiet. Okay? I promise, after an hour and a half, I will be finished. Then you can talk all you want. You go outside, you can also talk all you want. All right, so here we go. This is a print statement, and what I've done is I've passed in the number 56. This is not actually a print statement. This is called a print function. Things get a little bit blurred because statements and functions around print are kind of almost the same thing. But what this is a function. This is a function that I'm calling, and I'm saying, hey, Python, please print something. What do you think it's going to print? It's not a trick question. 56, okay, good. If you didn't know the answer to that, please go back and review INFS 1. All right, so here we go. Yeah, well, that was pretty exciting. Okay, it printed something. All right, well, we can actually print lots of other things. For example, if I were to say print 56 plus 2, what shows up on the output? Yeah, 58, because what happens is it does the evaluation first. Okay, everything inside the parentheses gets evaluated, and yes, it will take the 56 plus the 2, and yeah, it'll print the number 58. All right, so that means that we can print numbers. We can even print expressions. Okay, and yeah, this can be really useful because I can do some really, really weird calculations, like things like this, things that will take a little bit more time to do. And imagine this with a calculator, you have to do more stuff. Okay, so here we go. Sort of quick way of doing calculations. Okay, excellent. That's one of the things we can print. All right, here's another thing we can print. You can put quotation marks and you can print words like the print function. Okay, there we go. And yes, I know in 1101 you've seen this, but you may have missed a name. Okay, we'll cover the name in a second. All right, so what I'm doing this time is I'm printing not a number, but a string. Okay, oh, and not a big surprise when you run it. It says the print function. Okay, yeah, so well, that was pretty simple. Why? Okay, the one thing I wanted to point out about this is when you have a string, especially something with quotation marks around it, the name of this is actually called a string literal. Okay, that word becomes important. I'll point this one out in a second. All right, let's make some mistakes. I like making mistakes. Whoops, I made a mistake. Yeah, I forgot to put a closing parentheses. Nobody will ever forget that, right? Yeah, I saw this in the lab yesterday a whole pile of times. All right, so what ends up happening is it comes back and it says something very important. It says a whole bunch of red stuff, which scares absolutely everybody because suddenly it's just like, well, it's not doing what it's supposed to do. Okay, you know what? This is actually a pretty good result. When we see stuff like this, don't be afraid saying, "Oh, it's an error." No, look at it and go, "Ah, excellent! It told me exactly what's wrong." Yeah, this is actually a helpful error. All right, this falls into a category called a syntax error. Okay, I think the errors are all summarized at the very end, if I remember in the slides. All right, the word syntax error simply means you're not following the rules of the language. Okay, and one of the rules is when you have a left parentheses, you better have a closing right parentheses to go with it. Okay, and likewise, you can't have a right parentheses without a left parentheses. Okay, oh, and it's usually pretty clear. Let me make this so it doesn't pop up so often. Here we go. It's usually pretty clear because it'll say exactly what it was complaining about. It unfortunately doesn't tell you exactly what to do because it doesn't understand. It can't predict what you want. All it can say is that, well, there was a left parentheses that was never closed. But the good news is it told you exactly where the problem was. Yeah, syntax errors, this is what you want. You want errors? You want syntax error. And you'll have lots of syntax errors. I will have lots of syntax errors, and I apologize because I'll fix them very, very quickly. All right, here's another one. Let's put that one back. Let's make another mistake. And there we go. I forgot to put a second set of quotation marks at the end. Now, notice one thing about this is that the syntax highlighting is kind of showing that the closing parentheses is part of the string. That's why it turned green. If I run this one, you'll suddenly say that, okay, it's a syntax error. That's supposed to be the good one. And it says that it's an on-terminated string literal. Yeah, these are words you have to know. Okay, it isn't just like, oh, I got an error. You have to read the error. Okay, I've seen a lot of times where people have messages like this, and what they're doing is they're in here, they're changing names of variables, they're putting extra spaces and so on, trying to make it work, but that's not it. remember to make sure to read the error message that you get. So a non-terminated string literal means you're literally missing something at the end of a string. All right, but in any case, just because we're here, I thought I would include that. So we can print numbers and expressions. We can print strings. And, okay, well, we need to go back a little bit further. We need to have, let me see. Okay, I know a little bit later we will have a coffee. All right, and this is going to be the price of a coffee. I don't know, 17. It's way too expensive these days. But here you go. Here is a variable called coffee. Yeah, we'll see variables in a few seconds. I'm assuming that you will remember that from the previous course. And if I were to replace this with the word coffee, what are we expecting to see? 17, very good. Because you can not only stick numbers and expressions and string literals, you can also stick variables. And when you stick a variable, it will figure out the value of the variable because it will evaluate the expression first. For example, if you were to order 2 coffees, well, that would be 2 times coffee. And what do we expect? And now everybody's going through their head whether 17 times it.
34.
Yeah, 34. Okay, that's a double. Okay, I should have made it a bit easier. All right, so there we go. That's so 2 coffees is 34. Okay, excellent. So in other words, yeah, we evaluate the expression. That turns into a number. The number gets printed. But of course, something very, very important is make sure if you do this, it will actually print 2 star coffee because that is now a string literal. Okay, so pretty straightforward. Things inside quotation marks show up exactly as is. Things without quotation marks are evaluated and displayed. Okay, and that's simple as like the first slide. All right, now we've got a whole bunch of work here to do because we've got a whole bunch of things I really want to put together. All right, so we have coffee is 17. Okay, so I know we haven't really covered variables yet. We'll see it in a second, but I'd like to have some print statements. Okay, here we go. Oh, I better say is. Oh, said I'd make mistakes. No, I won't fix it. All right, here we go. So what I'm going to do is I'm going to print out a really exciting program. There's still no input yet. All it's going to do is it's going to tell you how much a coffee is. With a nice little bit of an output so we can actually see what it means. Because obviously just printing a number usually doesn't mean very much. 34, 17. I have no idea what that means. But if we can say that the price of a coffee is, and because I'm trying to print out the price of a coffee, the word coffee, or sorry, not the word coffee, the value of the coffee and the word reals at the end, okay, well, let's use 3 print statements to do it. All right, now, I think somebody will probably notice a mistake in here. Yeah, where's the mistake? Which line number?
3.
3, okay, good. You notice that I misspelled something. Yeah, I mean, I could fix that, but what's the fun in that? This is a legitimate mistake. How many times do you think you're going to misspell variables? How many times do you think I'm going to misspell a variable? It happens all the time. Yeah, some systems auto-complete things for you. They will highlight saying, ooh, hey, you have a variable here, but hey, it ends up happening. Okay, let's take a look and see what happens. Is that a syntax error? That's really the question. Remember what a syntax error is. Syntax error says that you're breaking the rule of the language. Okay, so we're talking about missing parentheses. We're talking about missing quotation marks. We're talking about using characters that we shouldn't be using. For example, everybody's been through 1101. You know very well that at the end of an if condition, there's a colon. You know that there's the word def somewhere. Okay, yeah, if you use these wrong, those are syntax errors. This is not a syntax error, but it's actually a very, very different type of an error. And again, I'm covering the slides quite a bit further ahead. Take a listen. Yeah, it's starting to bother me, actually. Okay, all right, so here we go. Something very, very different about this program. Okay, yeah, the program didn't work. And why did the program not work? You already know the answer why it didn't work. But the thing is, it isn't about why you know that this program didn't work. You need to be able to spot the patterns why your program doesn't work, because you're going to misspell different variables. All right, take a look at the error. So again, in fact, I would say like one of the most important things from the course is being able to look at an error and respond to it. We actually need to add more questions about this. All right, so here we go. We have something called a name error. A name error simply means you're trying to use a variable that does not exist. Okay. The great news about Python, you can just make variables wherever you want. But it actually said on line number 3, I mean, that's really cool. It said on line number 3, there's no variable called coffee. Oh, that's right, because on line number 1 was where it was supposed to be, but it's obviously spelled wrong. Okay, excellent. So we can fix that. I'll fix it in a second. The second thing that I want to point out, which is very important, did the program start? Yeah, the program started. You can tell because it says that the price of a coffee is. Okay, let me make a syntax error. There you go, there's a syntax error. Now I've got a syntax error and a name error. But take a look what happens when I try to run this program with a syntax error. Did the program even start? Yeah, that's actually how you can tell if you got a syntax error versus what's called a runtime error. The error happens when the program was running as opposed to at the beginning. Syntax errors are your most favorite because they're always very, very clear. It usually says pretty close what to do. The runtime errors can be a little bit more challenging because it just knows that something is wrong. It can't tell you how to fix it. It can just say that, hey, you know, when I hit line number 3, this happened. Okay, well, at this point, now you need to figure out what's wrong. All right, if I do stick this in, which we know is the solution, does the program work at this point? And the answer is, yeah, the program does work at this point. What do you think? Do you like the output? No, probably not, because I know what you want. You want the price of a coffee is 17 reals, all in a single line. Okay, yeah, well, we better cover that. And I know you guys did this in 1101. I just want to remind you, just so we don't end up having some problems. All right, I'm going to have to show you a whole bunch of different ways. Okay, the first way is not something that I use very often in the course, but I have to cover it because you might see it. Okay, but just to be reasonable. All right, after it prints out the price of a coffee is, any idea what happens next? Yeah, what it does is it prints off a special character at the end. You can't see it. It's called a new line character. And what it does is it causes the cursor to go down to the next line. Okay, and what somebody is just talking about is including an extra item here called end. Now, what I'm going to do is I'm going to put an X. Why? Just to see what happens. I like using X's all the time. Just say, okay, what happens? I'm going to run the program again. Okay, and then I can explain what it does. Okay, so the output now is on 2 lines rather than 3, and it says the price of a coffee is X17. That's kind of weird. All right, so what happens is when you say end is equal to X, instead of putting a new line character, it says put an X instead. Okay, so as a result, it doesn't go down to the next line, it just keeps on going. Of course, that's not a very useful thing because maybe what you really want is something like this. A space would be a whole lot better. All right, and the next issue is, well, if I want the word reals to show up in the same line as the 17, guess what I would do? I would do exactly the same thing here. Okay, now, don't dwell on this. This is not really that critical. There'll be a couple of questions on the first lab or something about stuff like this, but generally this is not the showstopper. We don't worry about the output in this course. We worry more about the logical processing of things, but I have to include it just in case you've seen it and just in case you do see it on one of the assessments. Okay, but it's not going to make or break your ability to pass this course. That will come with the dictionaries and the processing. Okay, all right, so there we go. That's one item. There's a second thing that we can also do. Okay, so here we go. You would have learned this definitely in the 1101 course. So let's do it this way. There we go, one line. Yeah, just commas, just one after the other. Okay, let's run it. Here, I'll clear the output so it's absolutely clear. Oh, hey, excellent, that was cool. Yeah, that does exactly what we want. And you'll see what it does is between each of the items, it puts a space automatically. Okay, again, this isn't going to be the end or the start of the programming of your career in this course. This is just some output stuff I included only because there'll be a couple of questions about it in the first couple of labs. Eventually things become really much more focused on the actual processing. Okay, so no, it's not going to be a course about printing. I will use this quite often. I will show you the other mechanism, and I know that a lot of students have seen it because I've seen this in the lab already. In my course, if I am printing things, which I will be doing for the first couple of weeks, I often use F strings. Okay, this is probably my most common approach for dealing with things, and the way how an F string works, and I know that this is done these days in 1101, here we go, clear the output. This is quite often how I display things. Okay, you'll see this used frequently. So this one, now you know where it comes from. So yeah, you could use the end is equal to nothing, or an empty or a space. Yeah, that works. It's just not that common. If you would like, by the way, I had some students yesterday say, can I do it this way instead by using concatenation, where I'm simply building up these big long strings? And the answer is yes, you can, but it comes at a small cost. Because if you try to run this, yeah, okay, here's the problem. You see, you can't take a string and add it to an int. You can take an int and add them together, but you can't take a string and an int. So if you wanted to be able to do this, exactly what I just heard is, yeah, somebody does a typecast over to the word string. All right, and somebody asked the other day, well, can I do this? And the answer is, yeah, you can. Oh, different course, actually. And I said, yeah, you can, but I mean, do you like this one? Okay, here's what I don't like about this one. Okay, any guess why I don't like this particular setup right now? Yeah, it's too long, I can't see it. All right, okay, no problem. There we go. Now I can see it. Oh, but you can't. Yeah, okay. This is always like the big trade-off is how do we deal with this? But you know, even for really long expressions, like big complicated math things, what do we do when the message gets too long? Okay, pretty simple. You just press enter. You can't press enter just anywhere, but at an operator, you certainly can at the plus. Okay, so just break things up so it doesn't get too long. Now, how long is too long? Ooh, okay. The official word, the official policy in the world of Python is 80 characters is too long. Anything less than 80 characters is okay. Oh, does that mean I have to go through? I don't enforce this rule, but that is a general convention that if you get really big file or really long lines, you want to break it up. Okay, this is not something I enforce, but if it gets kind of long, I suggest that you break it. But remember, that does not work. That's now a syntax error. Okay, here, I can show you. That's now a syntax error because it's an unterminated string literal because, well, you're missing something right here. You're missing the terminating quote because the rules are when you start a string, the string has to end on the same line. Okay, there we go. So the buzz going on back there. All right, so here we go. Let's make our program a little bit more interactive, please. Let's ask how much a coffee is and how much a donut is. Okay, so here we go. How do you get the user to type something as an input? The command is called? Input. Okay, excellent. All right, here's the way how the input statement works. What you do is you provide something called the prompt. And so we'll say, how much is a coffee? Okay, here we go. And I'm going to run the program, and it says, how much is a coffee? And I'm going to say it's 17. Excellent. That's really cool. It's like an incredibly boring program because it's not doing anything else. All right, let's also ask how much is a donut. Okay, how much is a, now, how do you spell donut? Okay, do you know the original Tim Hortons used to spell it this way? I don't know if they still do, but this is the first Tim Hortons I saw. They used to call it Tim Hortons donut, so I'm going to spell it this way. Okay. I know it's not spelled correctly. There's better ways, but it doesn't matter. It's just an input. All right, excellent. So how much is this? It's this, and a donut is, I don't know, 7. Why might we ask a user to enter the price of a coffee and a donut? Because we want to know how much they have to pay total. Okay, excellent. Now, you, again, know this from infs1201. When you read an input, okay, it stops, it waits, but to do anything useful with that input, you have to put it somewhere. Okay. Stored in a variable. Okay, so here we go. Let's have a variable. All right, so X and Y. Oh, yeah, I mean, those are variables. But unfortunately, if you got yourself a really big program, say a couple thousand lines, and you look at a variable called X and Y, does that mean anything? And the answer is no, it doesn't. Single letter variables, be very cautious about these. For right now, I'm basically just suggesting no. I will relax that a little bit when we hit the section on loops, when we start dealing with lists and structures and collections of things, and I will make it very clear about what is going to be allowed. Instead of using this, maybe C would make more sense in D. Okay, still maybe a little bit better, but I don't really like it. A variable called coffee, and once again, donut, so I don't have to spell out the big long one with the O-U-G-H and O-T. So I'll just use this one. I don't care if it's correct or not. All right, so what I'm doing is I'm storing these values. Okay. What did I say earlier? I said print statements are incredibly, incredibly useful. Nope, just this. I'm going to print them. I'm going to print coffee and donuts. Oh, if I run it, what type of error? Name error, very good. Name error, runtime error. Let's run it right now. Okay, so 17 and 7, good. 17 and 7, perfect. And my program is working. But of course, what we probably want to do is to add them together. Okay, let's add them together. Okay, so instead of printing them out separately, we'll add them together. Okay, so you go off to Tim Hortons, you ask for the 17 real coffee, you get the 7 real donut, and they say, thank you, that'll be 177. Okay, a little out of whack, right? All right, here is one of the deals with the input function. The input function always returns strings. Okay, they always return strings, and unfortunately, when you put a plus between two strings, it does something called concatenation. Okay, which I know, again, you've also seen in 1101. So you have to be very, very cautious about what's happening here. Just give me 1 second. Here we go. I might as well introduce the following items. Okay, I know it's a couple of slides ahead, but hey, I don't have to follow the slides as long as I cover them all. Okay, I'd complain and say, hey, who wrote the slides? Yeah, I know I put them together, but that's fine. It means I'm allowed to change them. All right, I'm going to introduce something new in this course called type. Okay, and I know you haven't seen this. This will tell you what type something is. Okay, this will be useful when you're debugging things. So I'm going to ask, what type is coffee? I'm going to spell the word print correctly in a second. And I'm going to type donut. Okay, I'm going to ask for the types of it. All right, ooh. You know what, I'm going to run it. Is it going to work? No, because obviously I've got a mistake. Oh, it's line number 3. All problems are in line number 3. Obviously that's not true. All right, so my question is what's it going to show? Is it a syntax error? Okay, how will we know? No. Okay, it will say, okay, but there's going to be something else going to be very important. Okay, remember, if it's a syntax error, the program doesn't start. If it's a runtime error, the program will start, and then it will have a problem wherever it occurred. Okay, so let's make a prediction. Syntax error where you don't see anything, or will I see the inputs? Okay, what do you think? Syntax. Okay, let's give it a try. Here we go. Here's a run. Is it syntax error? Definitely not. Yeah, but it's not following rules. Actually, it is following the rules. The rules are, you're trying to call a function on line number 3. The problem is that you tried to call a function called pert, and guess what? It doesn't exist. Now, here's the problem is, okay, I'm just put in 2 numbers here. The first 2 lines execute without a problem, but the third one generates the problem. And yeah, it's a name error, same as having a bad variable name. Now, here is a bit of an issue with this, and one of the things what I don't like about Python. Okay, and you might say, yeah, let's get rid of Python then. No, trust me, if I replace this with something that was much more strict, you would find it even incredibly more challenging. Okay, the problem that you're running into, especially if you've talked to students who have taken the course a bunch of times, not did well in it, it's not because it's Python, Python is, by the way, the thing that's making it easier. It's the programming language. It's the concept of programming and problem solving. That's what's making the course difficult, not Python. Python, this is the thing I don't like about this. The program worked until it didn't. Okay, no, put this into perspective. Okay, what do you think about this? You're working on a big report, you're writing a bunch of stuff in Microsoft Word, you're writing, suddenly you pull down one option and there was a runtime error and the whole program crashes and all your work is gone because somebody misspelled something. Does that sound fair? No. This is one of the problems about Python is it runs until it finds an error, then it stops. So it gives you a false sense that, yeah, my program's working until it doesn't. Anyway, just don't worry, we're still using Python, but it does happen to be one of these things. Okay, here we go. Let's run it this time. All right, so here we go. 6 and 6. Okay. Oh, and what's the total going to say? 66, because it's going to concatenate the two together. But I'm really interested in those two extra lines that I just included, which says this is a type str. Yeah, it's a string. I will be using this quite frequently in the class. You don't have to, but it's really useful, especially if you get stuck into a lab situation and you ask the instructor, like, hey, what's wrong with this? The lab instructor might sometimes ask, well, what type of thing are you looking at? And that's a good answer. That's the right way to answer. The wrong answer is, I don't know. Okay, because that's not helpful. It's not helpful to the instructor, and guess what? Not helpful to you either. Because eventually what will end up happening is somebody will start to use like square brackets to try and do string slicing on things that are numbers. And that's one of the questions is, what type do we have? All right, so how do we make these behave themselves a lot better? Well, what we do is we do typecasting. Okay, and yeah, I think I heard this when I wrote this. Somebody immediately said, yeah, this. Yeah, you know what this is. Yeah, if we typecast it to an integer, what this does is it takes the string 6, or sorry, the string containing 6, and it turns it to the number 6. If I try this right now, okay, so here, I'll do an 8 and a 12, just so we got something. Yeah, I still have an issue. That's a type error because I'm trying to mix things together incorrectly. But you'll see that coffee is now an integer and donuts are now strings, and you can't add those together. Oh, no problem. All I need to do is, of course, convert both of them. Here we go. So here's the 17 and the 7. Excellent. We got a 24. Suddenly things are making sense. They're both integers. Now, most of the time, although this is completely fine to put this right here and to actually print an expression directly, I'll be quite honest, most of the time people do things like this, where they will have an extra variable, something like total, and you'll say make it equal to coffee plus the donut, and instead of printing coffee plus donut down here, you might print the word total. Is that a requirement? Well, obviously it's not a requirement, okay? Does it make it easier to read? Yeah, that's the reason why we do this. It makes it easier. That's why you do things. And also, if you put it into a total, now we could calculate things like taxes and so on, or markups or discounts on the total if we wanted to do this type of thing. So that's quite often why people will end up doing things like this. Okay, a very important question I have to ask is this: what is the type of the total? I'll run it again. I'll get it ready. Here's a 7 and an 8. We know it's going to be 15. But my question is what type is total? Oh, good. I heard 2. Okay, it's a stringiger. Okay, no. The rules are quite simple. If you take an integer and add an integer in Python, you get an integer. Okay, so there we go. So it is an integer. No, it doesn't suddenly turn into a string. Okay, there's another type. Okay. Okay, somebody said it, a float. All right, so let's put it in as a float, and we'll stick it in as a float. The reason why you have a float is so that you can put in things like this, 17.6, and donuts are 1.2, and yes, it knows how to do this, and yes, the rules are if you have an integer and you add, or sorry, a float, and you add another float, you get a float as a result. What if you have a combination of them? Okay, here we go. So 34 for the coffee, super large coffee. 1.2 for the, oh, now here's an intro. Okay, you know what? Let me put this in anyway. Okay, I didn't write a float, I only wrote an int. Does that mean that coffee is going to be an int? And the answer is no, it's going to be a float because it says can cast it to a float. Okay, so it's definitely the coffee is going to be a float, which means now what I have to do is I have to print each of these. I'm going to have to print the type of coffee. Okay, print the type of donut. Okay, here we go. Let's run it again. 34. This was a really expensive coffee. All right, and a 14. Okay, so my question isn't what does this add up to, because we have a pretty good idea it's probably going to be 48. I think so. But my question is what type is coffee? Float. Okay, what type is donut? Int. All right, and what type is total? Float. Okay, good. I already have this. All right, because once you have a decimal point, then it kind of sticks. So yeah, an operation with a float and an int usually stays as a float. All right, now here's probably the most entertaining thing about this entire exercise that we just did. All right. Yeah, okay, so we have strings, we have ints, and we have floats. Excellent, excellent. We're going to be constantly making decisions. Is it an int or is it a float? No. Most of the stuff we do here is going to be ints. I'll probably use floats for the first couple of exercises because they're so simple. I have to tie it to something that's realistic. But generally, you'll find that in most programming exercises, they're integers. Floats hardly ever happen. You see, even things like your GPA, they try to keep it as integers as much as possible. Okay, yeah, they don't store your GPA, by the way. What they do is they store the number of credits and they store the number of units, and then they do a calculation. And yes, those things are floats in a general sense, but they don't actually store the GPA calculation. We try to avoid that. Even the bank tries to avoid these things, by the way. So if you go saying, no, I've got 100.56 reals in my account, they probably don't store it as a float. They probably store it as the number 10056. Because it's easier for them to deal with. Floats are really trouble for a lot of computers. So it is kind of funny because we probably put a bit of emphasis in 1101 saying, oh, it's very important, but actually, no. However, a lot of you will go off and you will do a course called Data Science and Analysis, or Data Science and AI, DSAI 2201. Actually, you will use quite a bit of floats there because it is a little bit more realistic stuff. But here, I'm mostly interested in logic. So it's strange because we make kind of a big deal out of something that doesn't even happen. All right, most of the time, integers. Okay, let's see. We've done this one. Okay, that's good. We've done that. Okay, that's excellent. Are we doing 42? Yeah, we're right on complex output with concatenation. Well, I've already done that. That's not a problem. Complex output with if strings, I've already done. Hey, I've already covered most of this stuff. Ooh, okay. I got a couple of examples in here I have to do. Okay. Okay, one shot. Okay, expensive stuff, but that's fine. All right, so just one quick little thing. Okay, so what do you think? Good program? Yeah, not a bad. I mean, it works. It's obviously pretty simple. What I have to do is I have to include a couple of very important things here because that's the next thing on the slide. I want to make sure that I cover it. The comments here is actually about comments. All right, so over in infs 1101, you probably learned that we have these things built in. Wait a second again for the noise to settle down. Okay, thanks. All right, over in infs 1101, you would have learned about this thing right here called a hashtag. Okay, and basically what a hashtag is, officially it's called a comment. And the idea is you use comments to leave comments for the people reading this program to figure out what does it do, how does it work, who wrote the program, okay? What does this program do? Okay, well, it gets the price of a coffee and a donut, again spelled incorrectly, and displays the output. All right. this is what comments are used for. It's a reminder to people about what it is that you've done. Okay, makes a lot of sense. Because you can imagine in a really, really big program, that can become really important. Okay, remember what I said, really huge programs might have like 500,000 lines of code. And if somebody takes a look through one part of the code and says, what's that variable for? It would be really, really nice if something was left for them to say, hey, this is what it is. Okay, there's a question, so I'll ask.
Yes, so what is in line 6, use F and then...
Oh, that's an F string. Yeah, okay, so remember what an F string is. I know that we've been covering this in INFSC 1101, but hey, maybe you took it at a time where it wasn't, that's fine. So what I'm doing with an F string, it says, display all of this stuff, but anything inside curly braces, if you find a variable, replace it with the value of the variable. Okay, it's a shortcut, it's a convenience, so that you don't have to use commas, you don't have to put pluses and so on. Okay, excellent. Okay, so that's the whole purpose of a comment. Okay, sounds useful, right? Yeah. Were you told about comments in 1101? Okay, yes and no. I suppose you got some kind of an instructions like you must always put comments? It kind of varies from person to person. I can tell you in reality what happens is a lot of people don't put any comments whatsoever. It happens. We've got one rule in here, but it's too early to talk about it yet. But on the slides, it is useful. Okay, it is useful, especially, okay, you guys are learning, and if you do something, it's not a bad idea to leave a message to yourself for later. Okay, usually I don't go and harp after people about putting these things in, but here's what I'm going to do is I'm going to write a comment right here. Okay, comments, by the way, sometimes show up at the end of the line. Okay, whatever you want. And basically everything after the hashtag is completely ignored. All right, so, but I'm going to put the line right here and I'm going to say, watch this. Useful comments? Okay, maybe for you. But for somebody else who actually understands programming, is it helpful? I mean, we already know what a print statement is. Of course, it's going to display the total. Computing the total, well, that's pretty clear. I'm computing the total. So in other words, this is what I call documenting the obvious. That's generally not that helpful. So the good news is in this course, I don't really push the commenting a whole lot. There's going to be a place where we're going to do it because there's places where it's really, really, really important. And that has to do with functions. Okay, because functions are fundamental building blocks of the overall program, and yes, those ones do require some comments. If you're doing something incredibly, incredibly weird, then it is useful. Okay, but am I doing anything weird here? And the answer is not really. I'm just adding two values together. It probably doesn't need it. However, when we cover functions, yeah, there's going to be some very, very critical things that I'll say, hey, make sure that you do. Here, let's hit this one. So everything after hashtags ignored, remind the programmer or somebody else what's going on. And trust me, a small program, not a big deal. You get a really big program with a lot of really weird questions or a lot of weird if statements, you're like, why did they do this? That's where the comments become really useful. Here, most of the things that we do, yeah, okay. I have to include it because I have to talk about it because it shows up in the notes, it shows up in the book. It's a good concept, it's just not many people follow it. Okay, and yeah, neither do I. Okay, next one up. Okay, let's talk about this program here. All right, guys, I'm slightly ahead of myself because on the very next slide, I've now got variables. Okay, do we have variables in this program? The one that I've got right here. Here, let me get rid of these unnecessary comments. I shouldn't be doing this. Oh, by the way, because I saw some students doing this in my lab section, I better point this out as well. Okay, I have to ask you something very important. Line 3 and line number 5. What's there? Yeah, blank line. Why did I put a blank line there? It made it a little bit easier to read. Why? Because lines 1 and 2 were the input. Line 4, and it was only line 4, is the computation, and line 6 was the output. Yeah, this is something that I do. I tend to use blank lines here and there to try and separate logic sections. Okay, is it a requirement? The answer is no, not particularly, but I encourage you to do it. The one thing that I definitely discourage you from doing is this. Okay, I did see some of this, and again, it's not to go and make fun of anybody, but double spacing your program by putting a blank line between everything is not helpful. It just makes it bigger and harder to read. I would actually prefer to see this version of the program than the double spaced version. Okay, use spaces to help you sort things. So if you're working on one section and then you're working on a separate section, that's a good place for a break. We're going to do stuff with loops. Yeah, having a blank line before a loop and after a loop, it's helpful. Okay, it really does help. But double spacing everything, no, that actually makes it really, really bad. All right, I have variables in here. Okay, I suppose first question is, how many variables do I have? How many variables in this program? 3. Okay, good. All right. So the way how you set a variable by changing it is you use a single equal sign. All right. So you can see here I've set this equal to the result of the input after I turn it to an integer. On this line right here, I'm setting total equal to the value of coffee plus donut because there were values that actually worked. All right. And the variables, well, as I said earlier, yeah, the variables can make a program easy to read or difficult to read. All right, well, here we go. So let's do this one. Okay, as I said, A, B, C. Well, this is now A, this is now B, and now this is C. It's the same program, does the same thing. And yeah, you can manage it because it's only 4 or 5 lines long, but as the size of the program starts to get big, like around 10, 15 lines, it's really hard to keep track of what is A, what is B, what is C. Use appropriate names. Okay, good. So we want to use some names. So I think I've got an example here in the next page. This would be fun to bring in. Excellent. So obviously you realize that, yeah, we would want to have like single letter variables is not very good. So therefore, let's go to the other extreme. Okay, now, something I have to point out. Okay. Let me just undo this. Okay, here we go. Hey, Control Z does work. All right, here we go. Instead of having total, what if I had order total? And order total. I mean, that makes it more clear. That's not just a total, that's the total of the order. What do you think? Why? Yeah, I know you should put an underscore. Why? Yeah, because as it's written right now, it's actually going to be counted, well, it's going to count it as 2 variables. It's going to hit line number 3, and it's going to say, I don't like this because I have 2 things before an equal sign. That sounds to me like a violation of a rule. Let's take a look at what happens. Yeah, that's a syntax error. Okay, it's a syntax error because we violated the rules. All right, so exactly what you learned from infs 1101. Yeah, an underscore is the way how you deal with this. This, by the way, is called lower snake case. Okay, here you go, so 8 and 8. That's called lower snake case. That is the style of variables that we use in this course. And by the way, that is actually a requirement. All right, I got myself over here a program. Okay, let's paste it in. There we go. Well, let's just try it and see what happens. All right, so I forget what we have to do. How many numbers will we enter? I don't know, 5 numbers? Okay, so enter a number, this number, this number, this number, this number, this number, and bang, there you go. So there was one number that was bigger than 100 and no numbers were less than 0. It looks like I'm doing some stuff for testing. All right, take a look at the variables. The very first variable, count of numbers greater than 100. That makes it very clear. However, does it make it easy to read? And the answer is no. There's 2 issues with this. The first thing is it's a lot of reading. The second thing is, well, somebody has to type it. Oh, I know, you'll say, yeah, it's copy and paste. Yeah, but you don't want to constantly be going back and copying and pasting things all the time. It works kind of in the courses we do here, but as you get into a real course where maybe your program goes across, say, several pages because you're hitting 4,000 or 5,000 lines, or you have multiple files, copying and pasting is not really a good option. However, obviously what I could do is I could call this X instead. Okay, there's obviously a correct answer here somewhere. What's the correct value? I don't know, maybe maybe you could just call it greater than or less. Maybe just call it the word greater. Picking good variable names is actually kind of a really useful and important skill. You learn it usually because somebody says, no, that's too long, or no, that's too short. Here's a general rule. Making it too short is generally not a good idea. Make it a little bit longer if you have to. Okay. Usually what I try to do is I try to find a single word that describes what I'm doing. Okay. That's always my approach. Find one word that works. If one word is not good enough, 2 words is fine. Beyond that, it's probably not a good idea. Okay. That's just general rule of thumb in programming when you're picking up variables. Try to make it 1 or 2 words. Okay, and you'll probably end up getting pretty good variable names most of the time. What else have we got? Ooh. Okay, by the way, I'm almost done. We'll definitely be finished within the time. Sorry, we have got a section over here I have to introduce you to. Okay, coding guidelines. When you go off and work for a company, generally what happens is when you first walk in, the very first couple of days, you get some training about this is what you're allowed to do, this is what you're not allowed to do. Okay, it's pretty reasonable. Like, for example, I'm supposed to come in, I'm supposed to show a syllabus, but I haven't done it yet. But in any case, if you go off and work in a programming company, one of the first things that you bump into, or the first thing you ask for is, what's the coding standards? Okay, so for example, is that variable okay? Yes or no? Now, I know you're going to say, no, I don't like it because it's too long. But that's not a rule. The rule is it okay? And yes, it is, it runs. However, there's rules that happen within the language, then there's rules that happen with wherever you're working. Okay, would I want a programmer using variables that look like this? And the answer is no, because it's too long, it's way too much. Okay, it works, I don't care, but it's way too much. And likewise, would I want just say the value A? And I wouldn't want that either. So remember what I said, my recommendation, 1 or 2 words. All right, so what these are, even though the program will work perfectly fine as it is, there might still be rules that you might want to follow. And why do people put in rules? They don't put in rules to make your lives miserable, they put it in to be consistent. Okay? In a big company, you have to work with a whole bunch of other people. And your program usually has to work with somebody else's program, because you're working on part of the program, somebody else is working on another part, and you can't have one style and another style. You can't have one person using single letter variables, the other person using 20 character file or 20 character variable names. I know in this course we don't collaborate like this, but it's something we have to keep in mind. But guess what? When I grade things, I've got to look at 20 of them. What I want is I want most of the programs to look roughly the same, not one person, 1 character, one person, 20 characters. I want to see things that are consistent. So what these are, this introduces the concept of coding guidelines. So I better show these to you because they will be enforced. Okay, you will lose marks if you don't follow them. They're pretty straightforward. They're not really difficult. Okay, but here we go. This is the current coding standards. I won't go through everything, but basically lowercase snake variables. That's lowercase, underscores between them. Okay, pretty straightforward. You don't have to memorize them, just follow them. Pick good variable names. Okay, I know we haven't covered for loops yet, but when I see the letter I, I don't think of students. Okay, maybe S for a student, but definitely not I. Okay, so good variable names. Pick things that actually make some sense. Doc strings for all functions, we'll cover that in a little bit. There's a bunch of rules in here about some things called advanced functional constructs and comprehensions. These are some super highly advanced things that ChatGPT knows how to do and infs1201 students don't. So therefore you're not allowed to use them. And if you say, yeah, but that's not fair, if I introduce these, then I get to evaluate you on them, and that is highly, highly complex, and I don't think anybody will enjoy them. Okay, so here's the rule. They're not allowed. So if you happen to have done a bunch of Python programming already and you know this stuff, you know what, that's fine. Not in this course. Because in this course, I have to keep everything at the same so that we can help the students who are learning how to program deal with the loops. That's why they're not here. There's another thing called inline if statements. Indentation is always 4 spaces, blank statements. Again, you're going to see stuff about this when we hit functions. Line length, remember I said try to avoid going over 80. I don't enforce this one, but try to avoid it. And no shadowing of built-in names. I'm glad I covered this. I better explain what this is. Okay, because I have a feeling you don't know what the answer is or what that even means. It's actually pretty simple. Okay, for this, I'm going to have to go back a little bit. Oh, perfect. That's pretty nice. Here we go, total. Okay, this program works perfectly fine, right? Okay, and we've already been through the fact that we can change the names of the variables. And if I change this to an X and I change this to an X, I'm going to ask, does it work? Yes, it does. Do I like it? Not really, but it does work. I would like to change it to a different variable because, I mean, if you add 2 things together, it's a sum, right? Okay, here we go, and a sum. Now, do you know something funny about sum? It's kind of a funny color. I'm going to run it. Well, I'm going to click on the run button, I guess, just so that you know, and I'm going to ask, what do you think? Is it going to work? Okay, you're kind of suspicious about it. Okay, let's give it a try. Okay, here we go. Coffee is 5 and donuts are 6. All right, so if it works, I'm going to see an 11. If it doesn't work, which we think we're going to have an issue on line number 3. Obviously, we know it's not a syntax error. There you go, perfectly fine. Okay, so why the weird color? I mean, total didn't look like that, but sum does. Take a look at the color. What other words on here are the same color? Print and input and int. These are built-in functions. Okay, you should not, in the world of Python, reuse them. You can, but you shouldn't. Why? Well, because it makes the sum function impossible to use. My easiest solution here is watch this. Okay, I know it looks kind of weird, but here's what I'm going to do. If I said print is equal to coffee.donut, then I said I'd like to print the print. Let's find out. Okay, so 4 and 5, bang. You see, now I've got a type error, and it's very confusing. It says, hang on line number 4, it says that int objects was not, what? Notice that it didn't have a problem on line number 3. It actually went through line number 3. And what it did was it changed print from being the output function to being the value 9. Yeah, so now we don't have a print function. Now we have a 9. Okay, and now we can no longer print anything. That's the reason why you should avoid doing this. So at any point you ever type something and it shows up as purple, you go, oh, okay, back off, change it, pick a different name. Okay, don't call it sum, call it total. What if I already have total and I want a total and a sum? Pick a different name, because I think total and sum would be way too confusing. All right, the same thing would be true here. Like if I called an int, oh, here we go. So that looks like it's complete horrible, it looks like a complete horrible mess. So you expect this to actually fail completely, but no, it works perfectly fine. But unfortunately, you'll never be able to use int again in the rest of your program. Okay, so if something shows up purple, avoid it. All right, since we're here, we better do another one. Okay, which one have you seen? Okay, you've seen this one. Okay, what do you think? Okay, you remember while from the 1101, right? That's used for dealing with loops. Okay, this one here. Okay, here we'll clear this screen. All right, what do you think? It's probably going to work the same way, right? Actually, that's a syntax error right away. Because what happens is when it sees the word while, it's expecting an expression followed by a colon. And it doesn't find it, and it goes, whoa, you can't do this. So anytime that something comes up as orange, at least in our interpreter, idle is the same colors, by the way. We picked the same ones. Yeah, that's actually a reserved word. You can't use it for anything else. So if it's black, it's good. If it's purple, not in this course. Okay. If it's orange, well, not at all, ever, no matter where you go. Okay, let me see what else I've got. I'm almost finished. variable names to avoid. Good, I've already done it. Syntax. Oh, hey, excellent. Hey, we've actually done pretty much everything. So here's what I'm going to do. Let me pop open this slide. We'll just skim through it just to make sure I've got it. And I promise, like 5 minutes, I think we'll be done. All right, here we go. So options for print. I talked about the end. I'm not going to even bother with the set because we don't use it in the course. All right, the input function comes in as a string, so even if you type things, yeah. Type conversion, we talked about converting things into ints and floats and so on. That's all fine. What type is it? We've done that. Complex output with concatenation, we actually did a while ago, so that's probably the style you learned in 1101. That's fine. It works here. I would recommend the F strings instead, but I will never force it. I will never say, no, you can't do. No, entirely up to you. All you do is you enclose the variables in the curly braces and you put an F at the beginning. You leave the F out, doesn't work, by the way. Comments, okay, we talked about that. We've talked about the variables. X's and Y's are good if you actually have like X and Y coordinates. Otherwise, try to use variables that actually explain, use names that actually explain what the variable is holding. Don't make them too short or too long. Okay, exactly, I don't have any rules that says it must be this many characters. Just as my recommendation, 1 or 2 words usually tends to work. There's the example, okay. Oh, excellent. Here you go. Do you like that one? That was the first big one. Yeah, and we don't like it. And then I forgot it was here. Then I replaced it all lowercase. Yeah, I don't like this one either. Okay, it's, but strangely enough, this one's easier to read than this one, I think. Yeah. Okay, don't pick either of those. Actually, what, there's another one? Oh, I think this is the original one. I said, okay, this might not be so bad. Okay, so this is what I kind of consider to be kind of okay. Number of values, values entered. This is just too short. This is too long. Sorry, I forgot there was an animation in this one. All right, so the coding standards, I showed you the ones that are kind of important. Avoid like the variable print and so on. If you see purple, just change the name. If you see orange, you have to back off because those are the things. We've actually covered the syntax errors and runtime errors already. I forgot to cover logic errors. Oh, no, okay. Sorry, we're going to be an extra minute. Okay, here we go. We need to have, I can cover a logic error pretty quickly. Total. Okay. Any syntax errors? Okay. Any runtime errors that you can see? Okay, I don't think so. Okay, yeah, no runtime errors. Let's introduce a logic error. Logic errors are the worst possible things. Okay, somebody hit something, okay. They got the formula wrong. Now, when we have only a straight program without if statements and without loops, it's usually pretty easy to catch these things. But as you will discover, you're going to have a lot of logic errors. So you buy 1 coffee for 5 and 1 donut for 5, and it says that it's 25. Probably not what you want. And of course, the problem is that everything works completely fine. Nobody has stopped anything. It simply does the wrong calculation. Yeah, these are highly, highly dangerous. These are situations where the program runs, but it doesn't do what you want. This is not what you want. Okay, so here we go. In this course, all right, bad news for you. Okay, syntax errors, we usually don't look at the program that's being submitted at all. Okay, you have to fix your syntax errors. Runtime errors, okay. It kind of depends on whether or not we consider it to be a good program. If it's a runtime error that happens just occasionally, that means that you're going to get some partial marks. And if it happens all the time, well, maybe not. Logic errors, these are the ones that are by far the most tricky thing because they're hard to track down. And always people are asking us like, oh, well, I had some of the logic right. Well, at that point, it becomes an evaluation thing. Very, very tricky to deal with. But you want to make sure that you deal with the syntax errors for sure. And you want to try to minimize your logic errors. All right, in any case, unfortunately, as I said, there's no help from the interpreter. All right, so a couple of error examples. We've done lots of these. Oh, and then it says practice time. Okay, somebody's gone and they've added like a bunch of little MCQ questions on here. So we'll just skip through them. Sometimes I use Kahoot. I don't have any for today, so let's find out whether or not you know these. These are pretty quick. There's what, like 7 pages of this? It won't take very long. Okay, so what type does input always return? String. Very good. Okay, what does this program display? There's a trick because it's something I haven't covered. Yeah, because remember the input is a string. If we were to say print type of X, it would say string. And a string times 3 is, whatever they typed in 3 times. All right, next one up. Which of the following can be used as a variable name? Now, a bit of a trick, because you actually, I'm not even sure. I don't know who put these ones in here. I'm not sure if they've got the animation even set right. Okay, so what do you think? Which of the following would be a good variable name? This number 5. I don't know why both are being shown. Median, I think. Why not class? That's actually a reserved word. Now, it's a word that we never see in this course, so it shouldn't be here. So sorry about that. I didn't make that example. What about the word import? Okay, it would work, but, okay, there's 2 things. First of all, you remember the import up at the very top. That's one thing. Second problem with it, it's actually misspelt because somebody has done an autocorrect with an I. Okay, so somebody hasn't checked these carefully enough. Somebody said, oh, I made Abelis a question. So am I allowed to do that? And the answer is yes. Okay, but can I do that?
No.
Yeah, you see, there's the problem. So sorry about that. I got some slides to fix. So here we go. That was the actual plan. What? Oh, sorry. Well, I can't ask you now what this one is. Why is the name second input not a valid variable name? All right, here's one of the rules: is you can't start a variable name with a variable or with a digit. Okay. All right. Which would be a good name for a variable storing a zip code? Okay, I'm okay with this one. I think C. Like Z, no, too short. var2? Yeah, it doesn't explain what it is, so yeah, that'd be a better one. Okay, so which of the following is a oh, that's terrible. That's terrible. The question should be, which of the following is a string literal? Yeah, C, because this is the thing with the quotation mark. That's a string literal. Everything else could be a string. Okay, it's just, but it should say it's a string literal. Okay, sorry about that. Which line of code assigns a string to the variable email? C, yes. Oh, you know what? I want to do that one. Sorry, I know I'm dragging this on, but you know our class officially goes until 3:30. Okay, I promise it won't be that long. I actually want to do this other one because that one is really cool. Okay, here we go. Coffee is equal to 6. Donut, spelled incorrectly, is equal to 10. And total is equal to coffee plus donut. Okay, and I'm going to ask you an absolutely silly question. Okay, the output is definitely, well, sorry, there's a print hello. Okay, now my question is this going to run? Is this going to produce an error? It certainly looks like an error, right? Yeah, it certainly looks like an error, but guess what? It isn't. Yeah, because it turns out if you have a string on a line by itself, it's just completely ignored. What's the point? Yeah, there isn't. Okay, but it is there. Okay, it is there. Yeah, it's just kind of ignored. It's like this. If I wanted to say 23 plus 90, I can put it there. The program runs. It calculates 23 plus 90. It doesn't do anything with it, but it calculates it. There are a couple of weird things that happen here. Just clear and show that it works. There's a couple of weird things in Python, and that's some of the weird stuff, just because I saw it. Okay, so which is a valid string? Okay, so what do you think? Okay, so some people said C and C as well. B, I believe, again, it should say string literal. Okay, sorry, I'm going to fix some of these things. Oh. Why? Yeah, this one was, okay, I have a couple of issues with this. First of all, okay, you'll see this one. This starts with a single quote, and it ends with a single quote. So you say, yeah, that's it. This one starts with a double quote, and it ends with, what is that? That's a stylized quote. That doesn't match. But that's a double quote. It just hasn't been copied and pasted into the PowerPoint. PowerPoint and programming do not go together very well, by the way, so sorry about this. But this one's actually considered valid, but this one isn't. And the reason for it is because there's an extra quotation mark in here, and that actually throws it off. I believe that strings are actually in the next slide. So, all right, so which of the following is a valid string? Again, it should probably say a string literal. So let's try number 4. Why is it 4 now? I don't know who numbered these things. All right, is it random number C? Yeah, I would agree with this because you can have a double quote inside a single quote. But this one right here doesn't work because I got a double quote inside another double quote. Okay, sorry, you've got many of these. Okay, so which of the following produces the string 10? The answer is always C in these cases. Yeah, that's it. The first one will actually compute 1 plus 0. The B would actually, if you tried to compute this and print it, it would actually print 1 plus 0. Sorry, these things really need to be looked. I'm going to be more careful about running these things. I'd rather my own cahoots from now on. All right, and is there any more? Good, thank you, done. Okay, I will look carefully at these things next time because I thought these were in better shape. I'd rather run my own cahoots for these. So sorry I'm a couple of minutes longer than usual. I will always be finished by this time. All right, and see you Wednesday.